Hi advanced students, this is Dr. Mo, and in this video we're going to do part 1 of tank trouble. The big ideas in this video, you're going to be using trigonometry to calculate the position of the tank. I know that sounds scary, but it's really not too bad. It's math I think the sophomores could handle. And then you're going to be using a data structure called a vector to hold your bullets eventually. We're not going to get to that until the second video. And then for some of you it might still be kind of a new concept. We're going to be writing our own header files, but again, that's not going to be covered until a later video. You really should not be attacking tank trouble unless you're a 4th semester student or a 3rd semester student that has completed all of the 2nd semester stuff. So don't do this unless you've done Pac-Man and Tron and Breakout and all that other stuff, because I'm assuming you're pretty comfortable with classes and matrices, collision, and just generally using Allegro. Okay, so let's start talking. I'm going to front load a little bit of the math in this so we don't have to pause too much when we're going over the code. So tank trouble works by spinning a tank around to a certain angle using left and right arrow keys, and then moving backwards or forwards in that direction using the up and down. If you haven't played it, you should probably pause this video and take about 5-10 minutes or more to actually go online and play this thing, because it's very different motion, a very different motion algorithm than what we've been using so far in this class. So when you spin it, you're keeping track of how long the user holds the arrow down, and every couple game clicks, it's adding to that. And then the tank actually only moves forward or backwards when you press up or down. I think in robotics this is called tank drive, which works the same way with our robots. Okay, so you're going to need some pretty scary looking trig to figure this out, but like I said, it's really not that bad once you break it into its pieces. So let's go over it. It's only 2 slides. So the first thing I want to point out is the stuff inside the parentheses here. So ignore everything else and just look at this 3.14 times angle divided by 180. The trig functions in C, and I actually think pretty much all the major languages out there, work in radians. But the way that my program is doing this is it's calculating it in degrees. So before we feed it into this sine and cosine function, we need to take the angle that we're calculating it and turn it from degrees into radians. And that's a really simple formula. Hopefully you've seen it in your math class. If not, here it is. This is literally something my 8-year-old could do if he had a calculator, because all you have to do to convert an angle from degrees into radians is you just multiply it by pi and you divide it by 180. That's it. Okay? And as always, the beauty of math and computer science is the computer is going to do the lifting for you. You just have to tell it what to do. So you don't actually have to do that stuff on paper or in your head or anything. You just punch it into the code like a calculator. Okay, so this part here, just this part in the parentheses, that's just me converting from degrees to radians. Okay, so now let's take a look at the rest of the equation. The 4 times sine, and we're adding that to the y position, and then the 4 times cosine, which we're adding to the x position. So check out this, awesome slide I made in Paint. Yeah, I'm going to be in the next Khan Academy. It's going to be great. All right, so hopefully, again, you are familiar with some SOHCAHTOA trig. If not, don't worry about it, because if this quick explanation is not enough to get through it, I can go over this on the whiteboard with you. I don't know why people wait so long to teach this, because I think it's actually really easy math. You just have to basically know the steps, and you've got it. Okay, so SOHCAHTOA is just and bear with me, by the way, if you do know this, just, I don't know, draw a kitty or something. SOHCAHTOA is just a way to memorize what the different trig functions represent, okay? It's like PEMDAS. PEMDAS is just a way to memorize. Sorry about that. I had to yell at my 8-year-old and 9-year-old. He just turned 9. So anyway, so this is just a mnemonic. It's just like a little trick to remember what it means. Sine, the sine of any angle, is going to be the opposite side over the hypotenuse side. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Okay, so the only thing SOHCAHTOA does is just remind you that those are the ratios, the fractions that you set up. Okay, so let's say that our tank is up here at this little dot here, okay? And we want to go, the user has pressed the down button or something like that, and we want our speed to be 4, so we want to go 4 pixels in the direction he's pointing. And you don't really know where that is. You just know that from where you are, you want to go 4 pixels, and you know his current angle, because we've been keeping track of that. Every time the user presses the right or left button, we've been adding or subtracting to that angle. Okay? So given that angle, and given that we want to go 4, we need to actually calculate, okay, well, how far down do I go and how far over do I go? So I'm going to start on this over part right here. To figure out what this is, to figure out how far, what I'm going to add to my x component, is I'm going to set up this ratio. I know I have the opposite side, or I need to figure out the opposite side, and I have the hypotenuse, O and H. The trig function that has an O and an H is sine. So I'm going to set up this equation. Sine of A is x over 4. This is a true equation. Then, what I'm going to do is I'm going to solve this thing for x. How do you solve this for x? Well, you would just multiply both sides by 4, and all of a sudden, x is by itself. So going back to this first slide, if you take a look here, what we're going to do, and ignore the fact that this is y and x here, I'm sorry, this just has to do with the fact that, like, things get a little flipped in Allegro, as you guys know, so we can talk about why we had to do that later, as long as this math mostly makes sense. So you can see here's our 4, and here's our sine of angle, okay? So all we did is we just multiplied both sides by 4, oops, multiplied both sides by 4, so you have 4 times sine A, sine of your angle, equals x, okay? Repeat the same thing with y, and you've got that direction too. And notice that what we're doing here is we're adding or subtracting those solved equations to the x and y coordinates. So it's really important, if you see here, I have the plus equals, not the just straight up equals, okay? Because otherwise he's always going to be calculating from his starting point, whatever that is, okay? The plus is for forward, the minus is for backwards, okay? Cool. All right, so what I want you guys to do is I want you guys, I'm going to show you the code, don't worry, that's not all I'm giving you. I want you guys to get the tank and the map working. Don't worry about the bullets. I've left a lot of the code for the bullets in there, but it's all commented out. Please don't type that out yet, because it's going to be nasty to try to debug stuff with more lines of code. So all I want you to do at the end of this video is just make sure that your tank moves properly. The map is set up. It should be different than mine, okay? And then the collision kind of works. And what I mean by kind of is that, I'll be honest, my collision function is kind of bad, so it doesn't have to be any better than mine. Okay, so here's my program. If you run the code as a given, it's going to look like this. And right now I'm pressing, here's with the left arrow button, here's with the right arrow button. There's forward, and here's backwards. And collision is, you can see here, bonk. It's pretty good most of the time, but if you really play around with it, oops, like there's a problem right there. That's not so great. And that wasn't so clean. There's even some people who have played around with it and they can like phase through the wall. So that's not your fault if that happens. Just my collision's kind of sloppy because that's not one of the main teaching ideas here. All right, so I only have about 5 minutes to zip through this, so let's make it kind of fast. Nothing new here, so just let you look at that for a second. Oh, we do have pound include vector. Don't worry about that because, like I said, that's for the bullet, getting the bullets to work, and we're not going to talk about that in this video. Okay, here we have the map, and remember, laziness is a virtue. I never actually write out the whole map to do the walls. Instead, what I did is I set it all to 0. That's what's happening right here. And then what I'm basically doing here is saying, hey, if you're in the very top row or the very first row, the very first column, set it equal to 0. If you're in the very last row or the very last column, set your, I'm sorry if I spoke wrong here, you're setting it to 1. 1 means a pink wall. And then these are my inside walls here, okay? So I basically said, and this was just trial and error to figure out how this looked. But these walls that you see being drawn here are me just putting in ones in certain rows and certain columns in my matrix, which you can see here. If you want to actually draw out all 64 and 48, 64 rows and 48 columns, go for it. I just like this way a little bit better because it's lazier. It took less work for me. It just took a little more brain power. Okay, but if you want to go back to the way we did it for Pac-Man, that's cool too. All right, setting up Allegro. Ooh, I should have commented those out. Those are for, oh wait, not the angle. You need angle. Here's the variable that's keeping track of the angle that we're at. Just fired, that's a bullet thing I forgot to comment out. You don't need that yet. Setting up Allegro, this is nothing new as long as you've done a couple programs before, so I'm going to kind of go through this. Quickly ignore all this stuff that deals with the bullets. This should be commented out too. Sorry about that. Don't worry about that. So the first thing in your timer that we really care about is, right here. So the angle is getting messed with as we press the right and left buttons. You can see here, when left is pressed, we're subtracting one from angle, and when right is pressed, we're adding one to angle. And just so we don't ever get into a situation where we're overflowing, I am resetting my angle back to 0 after we hit 360, and then vice versa. If we go below 0, it gets back to 360. The code still actually will work if you take this part out, which is interesting, because you just have to realize that when you keep going, like the angle is the same. So for example, like the angle 370 is the same as 10, because we've just kind of gone around more than once. Yeah. Okay, here's this stuff that we already talked about in the PowerPoint. So there's the math in action there. Okay, hopefully that makes pretty good sense at this point. Bullet stuff. Nothing new here. I do have key M set up in advance. That's going to fire my bullets eventually. You don't need that yet. Nothing new here, as long as you've done Pac-Man or something with a matrix before. We're just drawing in. If it's a 1, we're going to have that pink wall. And feel free to mess with the colors. Feel free to have multiple different colors. You guys should be okay with that. Okay, so the last really new thing other than our bad collision function at the end is this function here. Draw rotated bitmap. It works just the same way as draw bitmap, and you've done that before. The only difference is that you're giving it an angle, which again I've converted into radians, and it's going to draw exactly as it says. It's going to draw it rotated. That's how I got my tank to actually spin around. If you notice here, that spinning motion there, that was all handled for me by that function, which made this a lot easier to write. So thankfully we don't have to do that our own. We just tell that function what angle to draw it at and what you're drawing, and etc. Okay, nothing new here. Aha, all right, so here's my not so great function, and if you guys can fix this up for me, I'd be super grateful. But it's the exact same thing as Pac-Man. What you're doing is, if you're going up, remember you're only going up or down, so you only need to like check that, is you're going to look 4 pixels ahead of where you're going to see if there's a wall there. So you calculate this new X and Y position that's either ahead of yourself or behind you, depending on which direction you're going, and you're just checking if there's a 1 there. So it's the same math as above, like I said, but the only difference is that you're just checking ahead of where you're going. So you stop yourself before you're actually in the wall. Cool. So like I said, if you guys could get to the point where you have this up and running, tank should move properly. You should have a setup map that you can collide with. The map should look a little different than mine. All right. Good luck and have fun.